I will be basically just doing the videos for the construction part with the patty paper. Points on a perpendicular bisector, there's a theorem, there's a relationship that happens when I'm dealing with points on a perpendicular bisector. So to do this, and I'll give y'all some patty paper so you can do these on your own, we're going to trace the segment CD as such. I'm going to trace even the endpoints. And we got D and C. Alright, so for it to be, for us to construct or draw or show the perpendicular bisector of this segment, we are going to first have to find the midpoint. So I'm going to fold it so they go inside. Like such. I can see with the crease, we have a bisector here, or at least we have a perpendicular. There's my point to show the midpoint. We'll put an M for that. I probably should put that to the side a little bit. And if I want to show this, because we want to show this on our note paper, I'm going to make sure this is lined up right. Yep, because it went over just a little bit. There is my midpoint. So, M, tick mark to show it's a midpoint. And then we are going to draw an actual line that's going to be perpendicular. And it's going to go through the midpoint. I'm going to add the box. Alright, so the investigation that I wanted you to see, and I'm hoping you can see this perpendicular, alright, is if I were to look at any point on this line, and let's give the line a name. Say line AB. Yeah, let's do that. Because then now I have a point on the line. And if I were to look at the segment or segment from the perpendicular bisector from on this line to the endpoint, okay? So let's go ahead and draw that segment from A to C to that endpoint. Well, there's a relationship that occurs when dealing with perpendicular bisectors and points on that perpendicular bisector. I'm going to look at the distance from A to C and the distance from A to D. And if I trace this segment and do some rotating, it should be the same length, and it is, as from A to D. And this is one of the properties. I can do this from any point. I could do it from B to C. B is on the perpendicular bisector. C is the endpoint. If I trace and look at the relationship from B to D, it should be, and it is, the same distance from B to C. So, any point on the perpendicular bisector of a segment is what we call equidistant. Equidistant from the endpoints of the segment. So, to show that it's equidistant from the endpoints of the segment, I'm going to do 2 tick marks here as such, and now I'm going to do 3 tick marks. Because I'm showing that basically what I know is, I know that AC is going to be congruent to AD, and I also know that CB or BC is congruent to BD. And if I basically see on your example here, and I know your copies might be kind of bad, but because I have the tick mark in the box, I know this line here is the perpendicular bisector. And so A is a point on that perpendicular bisector, B and D are the endpoints of the segment, then I know that AD is congruent to BA or AB based on the theorem, or points on the perpendicular bisector theorem. Based on this theorem over here, 5.1. So that makes me know that 5x plus 12 is equal to 8x. And then we can solve for x. Well, we see we get 3x, so x equals 4. Oops, I put 12. Sorry, divide by 3, 4. And so basically, I'm going to give you a figure that's similar to this. I'm showing you the tick marks as perpendicular and show you that there's a point on that perpendicular bisector and that it would be equal distance using the theorem from the segment endpoint. So that's all I needed you to do on that one. Thanks a lot.